Transformations. The graph of a function can be transformed by either shifting, stretching, shrinking, or reflection. The elementary transformations of a function f are captured in function notation as follows. Translation. Shifting up or down is given by f of x plus k. Shifting left or right is given by f of x minus h. Distortion. Stretching or shrinking vertically is given by a times f of x. Stretching or shrinking horizontally is given by f of bx. Reflection over the x-axis is given by negative f of x, and reflection over the y-axis is f of negative x. Shifting the graph of a function f of x up or down is given by f of x plus k and is called a vertical translation. If k is greater than 0, then the graph of f of x shifts up k units. If k is less than 0, then the graph of f of x shifts down k units. Consider f of x equals x squared, and two of its translations. G of x equals f of x plus 2, so that would be x squared plus 2, and h of x equals f of x minus 3, so that would be x squared minus 3. The graph g is the result when f moves up 2 units. The graph h is the result when f moves down 3 units. Shifting the graph of a function f of x left or right is given by f of x minus h, and is called a horizontal translation. If h is greater than 0, then the graph of f of x shifts right h units. If h is less than 0, then the graph of f of x shifts left h units. Consider f of x equals x squared and two of its transformations. G of x equals f of x plus 2, and h of x equals f of x minus 3. The graph g of x is the result when f of x moves left 2 units. The graph h of x is the result when f of x moves right 3 units. Translation of the graph of a function f of x is given by f of x minus h plus k. This includes shifting both up and down and left and right. Consider f of x equals x squared and two translations. G of x equals f of x plus 2 plus 1, and h of x equals f of x minus 3 minus 1. The graph g of x is the result when f of x moves left 2 units and up 1 unit. The graph h of x is the result when f of x moves right 3 units and down 1 unit. Reflecting the graph of f of x across the x-axis is given by negative f of x. So this is the graph of x minus 2 squared. This is the graph of negative x minus 2 squared. Reflecting the graph of f of x across the y-axis is given by f of negative x. So while this is the graph of x minus 2 squared, this is the graph of negative x minus 2 squared, or x plus 2 squared. Stretching the graph of f of x vertically away from the x-axis is given by a times f of x, provided that a is greater than 1. F of x stretches away from the x-axis by a factor of a. Consider f of x equals x squared and one of its transformations. G of x equals 2 times f of x. The graph g of x is the result when f of x stretches away by a factor of 2. Shrinking the graph of f of x vertically towards the x-axis is given by a times f of x, provided that a is between 0 and 1. F of x shrinks towards the x-axis by a factor of a. Consider f of x equals x squared and one of its transformations. H of x equals 0.5 f of x. The graph of h of x is the result when f of x shrinks towards the x-axis by a factor of 0.5. Stretching the graph of f of x horizontally away from the y-axis is given by f of bx, provided that b is between 0 and 1. F of x stretches away from the y-axis by the scalar 1 over b. Consider f of x equals x squared and its transformation h of x equals f of 0.5x. The graph h of x is the result when f of x stretches away from the y-axis. Shrinking the graph of f of x horizontally towards the y-axis is f of bx, provided that b is greater than 1. F of x shrinks towards the y-axis by the scalar 1 over b. Consider f of x equals x squared, and its transformation, g of x equals f of 2x. The graph g of x is the result when f of x shrinks towards the y-axis. Use the function f of x equals x squared minus 1 for each problem below. Write the rule or formula for the new function after the transformations. Alright, so f of x equals x squared minus 1, so we have 3 times f of x plus 4. So let's have that equal 3 times, and now we're just going to plug x plus 4 in here. So we have x plus 4 squared minus 1, and this 3 is multiplying times the entire function. So that's going to be equal to 3 times x plus 4 squared minus 3. The next one, this is going to equal f of 5x minus 3 plus 2. So first thing we're going to do is take this function and plug 5x minus 3 into it. So that gives us 5x minus 3 squared minus 1, which is the function, then plus 2. So that gives us 5x minus 3 squared plus 1 when we combine these like terms there. All right, now we have 1/2 times f of x minus 5 minus 4. So let's take 1/2 and we're going to multiply that times f of x minus 5. So that's x minus 5 squared minus 1. And then we have minus 4. So that's going to equal 1/2 x minus 5 squared minus 1/2 minus 4. So that's going to equal 1/2 times x minus 5 squared minus 4.5, or I'll just write 4.5. To finish these problems out, you can also expand and multiply them all the way through to standard form. So for A, that would be 3x squared plus 24x plus 45. For B, that would be 25x squared minus 30x plus 10. And for C, that's 1/2 x squared minus 5x plus 8. Domain restriction. If the domain of f of x is a is less than or equal to x is less than or equal to b, then the domain of f of kx is a is less than or equal to kx is less than or equal to b. Exercise A. What is the domain of g of x if g of x equals f of 5x? All right, well, the domain here is from -3 to 5. So if g of x is f of 5x, that would be like this. And then we would divide each portion by 5, and we would have -3 over 5 is less than or equal to x is less than or equal to 1. -0.6 is -3 over 5, but in decimal form, is less than or equal to x is less than or equal to 1. The graph of f of x is shown. Its zeros are -12 and 4. What are the zeros of the function g given by g of x equals f of x over 3? All right, so we see here that f of -12 equals 0. And we're trying to find the zeros of the function g, so this is going to equal g of x, which also equals f of x over 3. So all of these are equal. Now, we see here that f of -12 equals f of x over 3, so we can set these equal to each other, what's inside the parentheses. That gives us x over 3 equals -12, or x equals -36. If we do this again, but for the other 0, we have f of 4 equal to f of x over 3, which equals 0. So we could set these equal to each other. X over 3 equals 4, or x equals 12. So at these points, those will be the zeros of the function g. -36 and 12. Let f of x equal 8x minus 2x squared. Its graph is displayed. The function g is given by g of x equals f of 0.5x. Carefully sketch the graph of g of x on the grid to the right. Label at least 3 points on the graph of g. From the graph, we see that f of 2 equals 8. And so if we want to know where this point is going to move to, we can just say, well, what point g of x equals 8, and then g of x equals f of 0.5x. So these are all equal, which means that we can set f of 2 equal to f of 0.5x. Therefore, 2 equals 0.5x. So when we solve for x, we see that x equals 4. So when x equals 4, y is going to equal 8. So this point has now moved over here. I'll make this green. So basically, every point on the graph of f of x is going to have the x value doubled. So when x equals 1, y equals 6 for f of x. Therefore, now when x equals 2, y will equal 6. Down here we see that on f of x, f of 4 equals 0. So now f of 8 will equal 0 because we have f of 4 equals 0. And when we're trying to set 0 equal to g of x, because we want to figure out the 0 of g of x, we see that g of x equals f of 0.5x. So because all of these are equal, they all have the same y value, 0, we can set 4 equal to 0.5x. Therefore, x equals 8. So now we have our new graph that looks something like this. I'm not very good at drawing parabolas, but there we go. That's better. Okay. B, write a formula for g that does not involve f. So let's figure out what this is. F of 0.5x equals 8 times 0.5x minus 2 times 0.5x squared, which equals 4x minus 2 times 0.25x squared, which equals 4x minus 0.5x squared. So this is our new function g of x. All right, here's a much nicer drawing of that parabola, and we have 4x minus 0.5x squared. Let f of x equal 6x minus x squared, shown here in red. The functions g and h are given by g of x equals negative f of x and h of x equals f of negative x. Sketch the graphs of g of x and h of x on the grid to the right. All right, so g of x is a reflection across the x-axis. So the line of reflection is the x-axis, which means that this point and this point will remain where they are, but this point is going to reflect down to here. So this point is 9 units above the x-axis, and this point is 9 units below the x-axis. So if we draw our new graph of g of x, it looks something like this. I'm not good at drawing these, but there we go. All right, and then h of x is f of negative x, which is a reflection across the y-axis. Since this point is on the line of reflection, it remains where it is, but this point, which is at 6, is going to reflect across to negative 6. This point, which is at 3, is going to reflect across to negative 3. So we can draw our new graph. H of x looks like this. Write formulas for g and h that do not involve the function f. Okay, so negative f of x equals negative 6x minus x squared, which is negative 6x plus x squared, or if you want to reverse the order, x squared minus 6x. And we have h of x equals f of negative x, so f of negative x equals 6 times negative x minus negative x squared. So that would be negative 6x minus x squared. All right, there we go. Here are drawings of g and h, which look much nicer than the ones I drew on the previous slide, and we have our new functions right there. Now that you've seen how each transformation is applied separately, consider an equation with multiple transformations. What goes first? Any thoughts? If y equals a times f of bx minus h plus k, to combine transformations, use the following order. First, do the horizontal shift of h. Then you're going to stretch or shrink horizontally with b or vertically with a. Then we'll do our reflections across the y and or x-axis. Then the vertical shift of k. Let f of x equal 6x minus x squared. Its graph is displayed. The function g is given by g of x equals negative f of x plus 3 plus 6. Write a formula for g that does not involve f. Carefully sketch the graph of g of x on the grid to the right. Label at least 3 points on the graph of g. Describe the transformations that map f of x to g of x. All right, so let's begin with the first part, A. I'm going to cover up these so that we have some room. to work. All right, so let's figure out the formula for g. So we have g of x, actually I won't repeat that. So negative, all right, so the whole thing here is going to be negative. Then we're going to have f of x plus 3. So we're going to write the whole function out and plug in x plus 3 for x. So 6x plus 3 minus x plus 3 squared. So that whole thing is negative. And then at the very end, we add 6. So let's take care of the inside of the parentheses first. So this becomes 6x plus 18 minus, all right, now this is going to be, we're going to use FOIL here. X plus 3 squared is going to give us x squared plus 6x plus 9. And then we still have that plus 6 at the end. All right, so this negative sign is going to switch all of the signs inside here. So we still have that negative sign on the outside. 6x plus 18 minus x squared minus 6x minus 9 plus 6. All right, so we're going to combine some like terms. So instead of having 18 and negative 9, let's just make that positive 9. Just do that there. We also have 6x minus 6x, so these are going to cancel. And then we're going to have this negative sign that we can now distribute in there. Negative x squared gives us positive x squared minus 9 plus 6, which equals x squared minus 3. So this is our new function. All right, so here's all the work, and we end up with x squared minus 3. On the next slide, we're going to sketch it out. Graphing x squared minus 3 is pretty easy. We start with our parent function, which is x squared, and then we just shift it down 3 units. So you see g of x here in black. We have the vertex at 0, negative 3. We have at x equals 1, we have 1 squared minus 3, which is negative 2. And then we can mirror that point across the axis of symmetry, which is the y-axis, and we get a mirror point at negative 1, negative 2. While it was very easy to just graph the new graph of x squared minus 3, we could also do it by going through all the transformations of f of x. So first we would move to the left 3 units, so that's here in green. So we have our red graph, move it to the left 3. Then we would have the reflection about the x-axis, so the negative sign out front is going to flip the whole graph upside down, which gives us the purple graph, and then we vertically shift it up 6 units from down here. So the vertex was here, now it's up there. Let f of x equal 4x minus x squared. Its graph is displayed. The function g is given by g of x equals 2 times f of x plus 1 minus 2. Write a formula for g that does not involve f. Carefully sketch the graph of g of x on the grid to the right. Label at least 3 points on the graph of g. Describe the transformations that map f of x to g of x. All right, so first I will write the formula. So I'm going to cover these up to give myself a little extra room. All right, so we are going to figure out what this is. So it's g of x equals 2 times f of x plus 1 is 4 times x plus 1 minus x plus 1 squared minus 2. So right, this equals 2 times, this portion here is 4x plus 4 minus, we'll use FOIL to figure this out, that's x squared plus 2x plus 1, and then minus 2 at the end. All right, so let's figure, we have to switch all the signs in here because we have a negative sign here. So that gives 2 times 4x plus 4 minus x squared minus 2x minus 1 minus 2. Combining like terms, we have 4x minus 2x, which is positive 2x. So I'm just going to get rid of that 4x and make this a positive 2x. And we have 4 minus 1, which is 3. So I'm just going to cross that out and replace this with a 3. All right, now we have 3 minus x squared plus 2x. We'll multiply all that by 2. So we have 6 minus 2x squared plus 4x minus 2, and 6 minus 2 gives us 4. So in rearranging a bit, we have negative 2x squared plus 4x plus 4 as our new function g of x. And there we go, negative 2x squared plus 4x plus 4. The next step is going to be graphing our new function. All right, so if we plug in some points, if we plug in 0 here for x, we get 4, hence the point here, 0, 4, the y-intercept. If we plug in 1 for x, we get negative 2 plus 4, which is 6. So we get this point here, the vertex. And then we can mirror this point across the axis of symmetry, and we can draw out our new graph of g of x. Walking through the transformations, we start out with our red graph here, f of x. Then we move the whole thing to the left 1 unit because we have this plus 1 here. So that's the black parabola. The red one moved to the left 1. Then we vertically stretch the black parabola into the green parabola because we have the factor of 2 here. So now we have the green parabola. And then we are going to vertically shift down 2 units because we have this negative 2. So we take the green parabola and move it down 2, and we end up with the purple graph of g of x.